For this problem, I'll start by finding my m and n terms. An exact differential equation should be in the form m dx plus n dy is equal to 0. To get it in this form, I can subtract that term to the other side. I'll get x minus y cubed plus y squared sine of x times dx minus 3xy squared plus 2y cosine x dy is equal to 0. I can distribute this negative to both of those terms. Now it's in the form m dx plus n dy is equal to 0. Our m term is going to be the coefficient for dx, which is x minus y cubed plus y squared sine of x. And the coefficient for dy is going to be our n term, which is negative 3xy squared minus 2y cosine x. We can now find the partial derivative of m with respect to y. That's going to be negative 3y squared plus 2y sine of x. We also need to find the partial derivative of n with respect to x. That's going to be equal to negative 3y squared plus 2y sine of x. Because these two terms are the same, we know that this differential equation is exact. We now need to find the integral of m with respect to x. So it'll be the integral of x minus y cubed plus y squared sine of x dx, which is going to be 1/2 x squared minus xy cubed minus y squared cosine x plus g of y. This is our function. To find g of y, we can take the partial derivative of this function with respect to y. This is definitionally equal to n. So we can now find the partial derivative of that term there with respect to y. It'll be negative 3xy squared minus 2y cosine x plus g prime of y. Earlier we said n was equal to negative 3xy squared minus 2y cosine x. We can set that equal to this term here. And we'll find that this 3x times y squared term will cancel, and this negative 2y cosine x term will also cancel, and we'll be left with g prime of y is equal to 0. We can now take the integral of both of these sides with respect to y, and we'll find that g of y is also equal to 0. We can plug this in up here for the function. This g of y will be 0, so we can write it as 1/2 x squared minus xy cubed minus y squared cosine x is equal to c. And that is our final answer. If this video helped you, consider subscribing.